Dear participants, welcome to Breakout Room number 2 of Invest Horizon eForum Sustainability. My name is Tina and I'm happy to be your facilitator today. Before we start, please be aware that this session is being recorded and if any of the companies doesn't want to be recorded, please just say so in the chat and I will pause the recording while you speak. Also, before we start, I would like to remind you about the format of this session. Each company has 5 minutes for presentation, 4 minutes for Q&A from our experts, and 1 minute for the experts to evaluate the company in our online evaluation form that I will provide in the chat. Also, I would like now to invite the experts to quickly introduce themselves, and we will start from Bernd from eCapital.
Yeah, thank you very much, Tina, for having me. Yeah, my name is Bernd. I'm a partner at eCapital. We are a German-based venture fund investing for 20 years in Series A stage technology companies. Our latest fund has a volume of 130 million euros, and we typically invest between 1.5 and 5 million euros.
Great, thank you very much. And now, Maximilian.
Hi, thank you also very much for inviting us. And from the list of experts, I can see it's going to be quite a few from Germany. So Hightech Wunderfonds is also a German VC. We invest in the early stages of the business, companies that are less than 3 years old and have a sort of remit to invest here. Our ticket size of the order between 500,000 to 1 million euros. And we have a fund of short of 1 billion and make 40 investments a year and see hydrogen or the clean hydrogen space as a very interesting market. And I'm looking forward to the session today.
Thank you, Max. And now William from WBX Ventures.
Hi, Tina. Thank you very much. Yes, I'm also from Germany, but originally Dutch. So I feel European, at least European, I would say. I'm not a direct investor, but I'm helping B2B startups and especially scale-ups from all over the world to grow, to find lead customers, but especially also to find the right financing. And I also have been working as coach and expert in the Invest Horizon hydrogen pilot program that some of the startups that are presenting here went through already. I'm focusing on sustainability topics like transport, mobility, energy sector, and the construction sector. Thanks.
Thank you. And now Jens from Evonik Venture Capital.
Yeah, hi, good morning. I'm Jens from Evonik. We are a strategic investor from the chemical industry. We're investing in materials, chemicals, of course, also digital topics. I also was part of the hydrogen thing that William already mentioned. Happy to see some companies here again and looking forward to your pitches.
Thank you. And now Stefan from ZAS Ventures. Stefan, do you hear us? Okay, then we proceed with Lisa.
Hi, everybody. Nice to see you as well. I'm Lisa from UVC Partners. We are an early stage VC fund. Last week, we just announced the final closing of our new fund. It's 255 million in size. We invest early stage, so everything between pre-seed and Series A, do tickets initially between 500,000 and 5 million, and have a very strong focus on B2B startups within 3 main areas, which are enterprise software, industrial tech, and mobility. And with our new fund, we felt like sustainability is one like horizontal topic that we're putting a special focus on.
Thank you, Lisa. And now we proceed with Hans Georg from White & Case.
Hi, my name is Hans. I'm a partner at White & Case, which is an international law firm, and I'm part of the growth group here. And we are basically helping assisting startups in growing internationally.
Thank you very much, Hans. And now Richard from Nebula 42.
Good morning. Thank you for having me. Yeah, I'm not representing today an investment company. My role is current role is supporting projects and startups, mainly in strategy and implementation. My background is in energy sector, and yeah, hydrogen has been on and off part of my life in the past 25 years. So it's an exciting time again, and glad to be here. Thank you.
Thank you very much. Now, Marcel.
Yeah, thank you so much. Good morning, everybody. Like the former speaker, I'm not representing a VC company, but much more an accelerator, representing the Circular Bio-based Delta and the Green Chemistry Campus in the southwest of the Netherlands. We are an accelerator for startups with facilities for offices, labs, and also piloting. And we have an expert team to support you on your next scale-up phase.
Thank you, Marcel. And now Joost from Dow.
Greetings, everybody. Joost from Dow, part of Dow's corporate venturing arm. We are basically a strategic investor looking into companies in the material and chemistry space. Thank you.
Thank you. And Walter from IGC.
Morning, everybody. Walter from IGC. We are direct investors and accelerator for any kind of innovative company specialized in sustainability. We provided about 21 million in the last 6 years, blending funds from private and public investors. Thank you so much.
Great, thank you very much, dear experts, for being here with us today. Each one of you has very valuable expertise that I'm sure that it will be of help for our presenting companies. Now I give the floor to the first presenting company of the day, which is Ionomer Innovations. Benjamin, I will stop sharing my screen, and whenever you're ready, you may share yours.
Fantastic, thank you.
Thank you.
Pleasure to meet you all. I'm Dr. Brendan Britton. I'm one of the founders and Chief Strategy Officer of Ionomer Innovations, based in beautiful Vancouver, Canada. And we're a team of 35. We're a spin-out from Simon Fraser University and the National Research Council of Canada, commercializing advanced materials that are a platform technology for hydrogen. And on these, the most advanced hydrogen production systems, fuel cells, and CO2 to value systems can be built. We were working on these materials for more than a decade before commercialization, starting late 2017. And we have breakthroughs to replace the fundamental material set in PEM fuel cells and PEM electrolyzers, as well as unlock alkaline systems for advanced electrolysis that we firmly believe will be the most cost-effective green hydrogen possible. And so we have breakthroughs for industry, and on top of it can replace toxic fluorinated chemistry. And again, we're focused on these technologies being the center of the hydrogen revolution and the key market that we want to chase. These are really platform technologies for ion exchange materials. And at the heart of our innovation, we engineered out the groups that were susceptible to degradation and achieved the highest performing materials on both sides that have ever been shown in commercial materials. And so in green hydrogen, this is our amine material set is a game changer, unlocking AEM electrolysis. And AEM electrolysis has recently had targets set by the Clean Hydrogen Joint Undertaking, and I'll reference them later, but at the core of it, this enables a greater than 40% reduction in CapEx cost for a technology that can best match the intermittent renewables that are coming onto the grid. So it's a 2-for-1 solution that combines the benefits of both traditional alkaline and PEM systems. Traditional alkaline has low cost components, and that's about its only benefit. These are large 40-ton systems that exist in giant warehouses. And this is a technology that's over 100 years old, pioneered by Norsk Hydro, which is now Nel. And PEM electrolysis has been around since the 70s or 80s. I mean, I guess it went into the Gemini space program, but really it hasn't been commercial for that long. But really, this balances intermittent renewables well, but at an extreme cost of using platinum and iridium, not just as catalyst, but as coatings. And this is not a tenable technology. So we combine the benefits of these two, and we have stable materials. In CO2 capture, we're a stable platform, the first for this system, and enabling a 3x versus incumbent materials. And in fuel cells, we can replace naphthalene with the only REACH-happy materials for the future of this technology. This is a large and growing market, over $1 billion today, but growing rapidly on the basis of these technologies. And these are the targets and reference that I just talked through. And one important thing that is overlooked is that naphthalene, which is the basis of many electrochemical technologies, is also very toxic. It's a perfluorinated alkyl substance, and well under an essential exemption right now, will not be for the long term. And so many large companies are turning to us as the only viable materials for directly replacing naphthalene in electrochemical devices. And this effort is largely driven by the European Commission, and many other agencies like the EPA are following along in their footsteps. So Ionomer has the only team in the AEM space that can scale. We're a merger of the team that brought consumer Wi-Fi to the world and polymer experts with deep experience related to very difficult technologies in polymer chemistry. And we're scaling today. We've produced hundreds of kilograms of polymers, which is enough for thousands of square meters, enough to support not just large pilots, but full installations and product lines. We're in the process of implementing ISO and bringing up a facility in Rochester, New York. We're looking to expand into Europe and North Asia in the coming year, and would have done so already without travel restrictions. And we're in the process of closing a Series A for $15 million US, and there's enough interest on the table that we're looking at an A+ in the first half of this coming year. So very interested if this fits your targets. We've been recognized for both of our materials platforms by some of the top awards in the world, and have over 50 commercial customers, including large corporates, in all of these market verticals. So that is the high level of Ionomer, and thank you for your time and attention.
Great, thank you very much, Benjamin, for your presentation and for being sharp on time. Now we have 4 minutes for questions from our experts. So whoever is ready may begin. Okay, do we have questions? Anyone? Or feedback?
Yeah, maybe one question from myself. Benjamin, thank you very much for the presentation. Very interesting to hear. Can you elaborate a bit more on your go-to-market strategy, especially on how do you convince customers to buy such large projects, and how do they buy your technology?
We're a pure play material supplier. So many of our competitors in the AEM space are looking at integrating vertically, but we believe that making materials is difficult enough. We also have an asset light strategy. So we don't believe in doing anything in-house that we can do more cost effectively out of house. So we partner with large chemical suppliers to make our polymers, as well as partner with film coaters to make our films. We do have pilot capacities to what would be considered large scale in-house, so 100-liter reactors. And we have a pilot line that can produce, hundreds of square meters a day, but it's not enough. We need partners. And so we truly do have an asset light strategy. Our goal with the A and A+ is to get beyond break even and to an inflection point in 2024, 2025, where we're pulling in more than 50 million per year at a good gross margin that we hit break even and scale from there. And yeah, so asset light in a chemical manufacturing sense is about that.
Thank you.
Thank you. And do we have any more questions or feedback for Benjamin?
Yes, also thanks a lot from my side for your very interesting pitch. Could you maybe lay down the risks or the main risks that you're facing as you're scaling?
Absolutely. The time to integration is the biggest business risk. We've faced down many of the technology risks, and one of the largest companies in the world has done a deep dive on our chemistry on both sides and said that it was scalable. We need to get to device demonstrations of real installs in long times. And so we have, for instance, we're at say 3,500 hours for a qualifier large pilot system with our AEMs. That qualifies the first megawatt pilots, but these first megawatt pilots going out next year need to last the test of time as well. And that's a risk just in partnerships. And if these pilots have challenges, then it delays our time to revenue. So we see it as a time to revenue risk. We have a realistic assessment of the design in cycles and a very detailed and not terribly optimistic bottom-up funnel that goes into this and our projections. And what we do to sort of make up for the depressed look at our chain is to have secured quite a lot of upside with our suppliers, so that if the market does turn around and rapidly adopt these technologies, that we're ready for that as well. But we're very conservative in our projections.
Great.
Can I have a final question, maybe?
Yes, of course.
If I recall well, you asked for your coming series 50 million. There's a lot of interest. How much do you still need? What is your ask at the moment?
So it was 1.5. So 15 million. This is 3 large strategics, two European strategics who have co-led, and another Fortune 100 company strategic. So this next round, we would love to put sort of middleware strategics in, as well as say a purely financially motivated VC would be very welcome, just to balance things out on the board and with the future trajectory of the company.
Okay. Thank you.
Great. Thank you, Benjamin, for your presentation and for your time. Now, dear experts, I would like to remind you that the evaluation form is in the chat. Please keep it open until the end of the session, because it is the same for all of the companies. Now you have 1 minute to fill it out. And in the meantime, I would like to invite our next company for the day, which is DiviGas, and Stefan to prepare his slides.
A short question from my end. I cannot open the survey. I get not found. Is it only for me, or have everyone the problem?
It's for it should work. What kind of message does it show to you? Maybe your antivirus system blocks it, and you can try from the phone or from other browser.
Okay, I will try it, but I got 404 not found. So okay.
Interesting.
For me, it works.
Okay.
Okay, then it's a problem on my end. Thank you. Then I will try with the phone.
No problem. Yes, just try with the phone or with other browser or incognito form as well, because sometimes the antivirus systems block it. Thank you.
Okay, thanks.
Okay, Stefan, we see your slides perfectly. We will begin shortly, just to give some time to our experts to fill out the form. Thank you.
You talking to me?
Yes, we will begin in a few seconds. We see your slides perfectly.
Okay. Oh, my slide. Not my slide. Okay. Not my slide. It's good. It's not me, yeah? Here, Stefan.
Me.
Smith. Okay.
Sorry, I got caught out before.
Stefan Smith from DiviGas. Okay, Stefan, if you feel ready, we may begin your presentation.
Sure, thank you. Good morning, everyone. My name is Stefan Smith, and I'm currently the Head of Strategic Projects at DiviGas. Alongside the accelerating shift towards hydrogen as a more sustainable and low-carbon energy source, hydrogen is also a critical chemical in the production of several major commodities, including petrochemicals, gasoline, fertilizer, and other specialty chemicals. With the growing importance of these value chains going forward, using hydrogen efficiently will be increasingly important over the coming decades. However, up to 15% of this hydrogen generated is lost due to challenges in separating it. Current methods of purifying hydrogen involve costly pretreatments, toxic chemicals, and are not well suited to the harsh conditions of industrial processes. Recovering hydrogen from these streams is often not economically viable, and so the gas is often flared off. DiviGas has developed a proprietary membrane that is able to selectively capture this otherwise lost hydrogen from these harsh gas streams. Strands of these polymer fibers are bundled together into a stainless steel module, and when in use, hydrogen passes through the membrane while all of the other gases are left behind. A key advantage of our technology is that unlike other membrane technologies, ours is resistant to the high temperatures and aggressive contaminants that degrade these membranes. Existing processes often require several pre-treatment stages and cooling to low temperatures before they can be used. This cooling, however, causes a secondary issue. At low temperature, hydrocarbons in the stream can condense on the membrane surface or within the absorbent and cause fouling and low performance. DiviGas's technology operates at much higher temperatures, preventing this issue. Finally, DiviGas's membrane also is highly selective for hydrogen over other gases, including water and CO2. In certain conditions, it can produce hydrogen at as high as 99.95% purity at good flow rates. In addition to applications in refinery recovery of hydrogen, this technology is competitive in a number of other processes for the production and storage of blue and green hydrogen. Examples we have looked at include carbon capture within hydrogen plants, production of hydrogen from biomass gasification, storage, and then subsequent recovery of green hydrogen, and several others. Worldwide, the demand for hydrogen is expected to grow rapidly over the next 30 years. While considerable focus is on the production of blue and green hydrogen from renewable sources, there is a considerable challenge involved with transitioning the existing grey hydrogen value chain. Our technology targets this immediate need for decarbonizing grey hydrogen at scale and could help create a large supply chain of blue hydrogen in the future. DiviGas has already received significant interest from other clients. Many of these clients process gas streams that contains more than $700,000 worth of gas in process, but is currently often being flared due to the difficulty or the cost associated with processing it and recovering that gas stream. It's simply cheaper to burn more gas. Our technology provides a competitive ROI for installing and recycling hydrogen from these gas streams. A key benefit of our technology is the significant quantity of carbon emissions prevented by recovering this hydrogen. For every kilogram of waste hydrogen recovered, 10 times that amount of CO2 is not released due to higher plant efficiencies. While it doesn't solve the issue, this is a significant step forward and can be implemented rapidly. The barrier facing other technologies doing this at the moment is the lack of separation performance. Our technology outcompetes many other membrane manufacturers on several key criteria. In terms of cost, it is significantly lower than other emergent materials and startups in this space, as well as being more robust than membrane technology supplied by our main competitors. The polymers used are based on research by Dr. Ali Naderi, CTO and co-founder, who has more than 10 years of experience developing specialty polymer membranes. We're currently patenting our wholly owned IP. However, crucially, our polymer cannot be reverse engineered from the final product, giving us some level of protection immediately. In August, we closed our seed round of about 3.6 million, led by Man and Hummel, supported by Energy Revolution Ventures and Vulture. This funding is currently being used to build a pilot scale manufacturing site in Melbourne, Australia, where I am now, and enable initial products for use on our clients in pilot scale trials. Following validation expected around mid next year, a Series A is planned, which will enable mass manufacturing and roll out across much larger projects and into other applications. On behalf of Andre Lorenzo, our CEO and other co-founder, I'd like to thank our many other founders and backers that have supported us to this stage. Thank you for your attention, and I'm happy to answer any questions.
Great, thank you very much, Stefan, for the presentation. Now it's time for questions, so we give the floor to our experts. Whoever is ready.
Yeah, Stefan, many thanks for your presentation. Could you elaborate a bit on your typical project size and how you can scale your business?
So our product size is currently relatively small. I should preface any of my answers that I've been in the job a week, so I'm still learning a lot of the ins and outs of the company. But our focus is to look at refinery scale. And so as I mentioned in one of my slides, the process streams for these could be are often in the millions of dollars. So we have a couple of clients we've looked at initial simulations for, where there might be a $10 million product installed, and the benefit generated by that would be usually about double that for that client.
And your thoughts about scaling the business with a large project size?
As considering the volume and prevalence of current gray technology, we are going to be looking towards partnering with a number of engineering firms in order to help develop skids, installations, and keep our focus on the manufacturing and development of the technology. So as we scale up, we would be looking at continuing to supply those modules because obviously they need reusing or resupplying over time, but we'll look to partners to scale up the technology and the engineering sites with clients, sorry.
Thank you.
A question from my end here. So on the one slide, you show that your robustness is better than of your competitors. Can you explain a little bit more about the USP in that case?
Yeah, so the robustness is critical for the point that generally in these processes, higher refineries, we have a lot of acidic gases, hydrogen sulfide left over, CO2 left over. These can cause plasticization or polymer degradation, and as well as the temperature. So we can operate as temperatures as high as 150. Most other membranes are well below 100. I think PSA processes are more like 40 or 60 degrees. So that additional cooling load gives us that advantage. Those other membranes are just not stable or in those conditions, and they'll degrade and require more frequent replacement.
Okay, thank you.
Okay, we have time for maybe one more question if anybody has.
Yeah, I have two quick questions. One is, when do you envision that your product is going to be a standard item for any large-scale refinery projects? That's one. The other one is, what's your understanding now? And the other one is, as far as I understood, part of your go-to-market strategy is partnering with EPC companies. What is your offer to an EPC company to make them consider you and to start with you? Thank you.
In terms of when I think this could be a standard product, that's a little bit challenging, but I suspect that as the hydrogen or the heavy industries is such a slow moving and very conservative space, we don't anticipate penetrating 100% for a long time. There's just too much risk aversion. Our current focus is developing that pilot scale to prove the technology works as it has done in our lab testing, and we've got a client who's corroborated on that. Once we have that, we then think scaling up will be important. The key point of getting engineering firms in or other partners in is the fact that we've had clients confirm letters of intent based on pricing and expectations of performance. So within that, there's significant scope for these other partners to take or to support that delivery, but we're still in discussions on what that exact deal looks like. Sorry, and I think I missed your second question.
No, you actually answered the second question. That was how do you approach and how do you consider working with EPC companies?
Okay.
Thank you.
Thank you.
Okay, thank you very much, Stefan, for your presentation and for your time. Now, dear experts, I remind you once again that you have to evaluate DV gas in the evaluation forum that is in the chat. And I would like to invite our next company, which is New Generation Tanks and Juice. Okay, great. Maybe full screen. Okay, we see it perfectly. Thank you very much, Juice. We will begin in half a minute.
Okay.
Okay, if you're ready, you may begin your presentation.
Thank you. Hello, everybody. My name is Gilles Rocher. I'm the founder of New Generation Tanks. It's a Swiss startup created in a context where we know that transport is a major contributor of both greenhouse gas emissions and air polluting particles. So we need to make mobility clean. For that, we have the battery technology, good for a small vehicle, urban use, short range, and the fuel cell technology, which is adapted to commercial vehicles. But for these vehicles and these technology, we need hydrogen storage solutions. And the problem is that existing pressure tanks are not optimized. They are heavy, they are bulky, they are not recyclable, they are limited in volume, and they may experience durability issues. So NGT is developing a revolutionary carbon fiber pressure tank based on a completely different design, another material and another process, allowing to make tanks that will be lighter, easier to integrate into vehicles. They are recyclable. They can be made longer with no more durability issues. The technology is patented in Europe and China, and it's patent pending in the USA and India. So comparing how conventional carbon fiber pressure tanks would be integrated onto a fuel cell truck chassis on the left, and NGT solution on the right. So NGT solution is lighter, it's more compact and easier to integrate onto the chassis. It offers more space, more payload, and a longer range to the vehicle. And if we look at a light vehicle, like a passenger car or a van, a set of NGT cylinders can be easily integrated into the floor, matching the concept of conformable pressure tank. And these benefits in the end contribute to the reduction of the cost of ownership of fuel cell vehicles. The market today for hydrogen pressure tanks is fairly small, but it's expected to be a multi-billion market by 2030, based on the expected number of fuel cell cars, trucks, and buses. And 2030 will just be the beginning of the growth of this market. So it's a huge market potential. The technology today is at TRL4, with some ongoing work to have this TRL4 validated in the next 2 or 3 months. The plan is to complete the development phase by 2024 and then go to industrialization. And to support this technology roadmap, NGT offers investment opportunities, so short-term investment opportunity of 250K to support the work of TRL5 to be validated by mid-2023. and then a medium-term investment opportunity of 1.2 million to support the validation of TRL6 by late 2024. And after that, there will be a longer investment opportunity to support the industrialization and growth phase of NGT. And this roadmap will have a number of milestones along from public funding coming from a European project of which NGT is coordinator, to tank certification and series sales through intermediate sales. So these funds will be used, the short-term and medium-term funds will be used to validate TRL 5 and 6 and complete the product development phase. The cost is mainly OPEX, and especially we need to grow the team. So I'm fully involved today in NGT, and Eric is the composite application development expert, and Steven, the future COO. They are not full-time involved in NGT, so we need to get them fully on board. We have together more than 55 years of experience, and we need to complete the team with more people to reach 8 people by late 2024. And NGT has the support today of an experienced advisory board. So to summarize the market, there is a huge potential today for pressure tanks and the great momentum for hydrogen and fuel cell vehicles. The product is innovative, unique, patented today at TRL4. The plan is very well defined. The team has to be grown further, but it's an experienced and motivated team. So I'm very happy to discuss with you if you are interested in supporting NGT in its development. Thank you.
Great, thank you very much for the presentation and for being so on time. Now we give the floor to our experts for questions and feedback.
Maybe I start. So you're not the only one working on this topic. What is really your USP on what is your technology better in than others?
Yeah, well, the technology ticks the boxes of weight saving, better integration onto a vehicle chassis, so that's the conformability concept, recyclability, and scalability. There are indeed some ongoing development, especially based on the conventional process, but with thermoplastic material, so filament winding with thermoplastic. But the fiber structure in the end is not optimized to use the best of the performance of the carbon fiber. And it's very difficult to get a good quality composite material with this technology. So we completely changed that, changing the design of the pressure tank. So that's a long, thin pressure tank with tapered ends. So that's completely different, and it allows to change the material, change the process, and build all these benefits of integrability, weight saving, recyclability, and scalability, because that's a thermoplastic material that we're going to use.
So you can also work with recycled fibers if you talk about sustainability?
No, because we need continuous fibers. But on the contrary, at the end of the life of the pressure tank, we can reprocess the material and use it for other applications like automotive component processed by compression or injection.
Okay, thank you.
May I ask you, how far are you in your prototyping? Do you already have some cars driving on this type of tanks, or?
No car powered with these tanks already. So the proof of concept has been validated thanks to experimental testing, burst tests actually made on prototypes. And there is a big work of simulation also that has been done. And today we are working on the improvement of the performance of the prototype made so far, and also on the selection of the right polymer. This is an essential parameter. The material is an essential parameter in the development of the technology. So by February, we'll have selected the right polymer after a big testing program to carry on the development.
Okay, thank you so much.
You're welcome.
And do we have any more questions?
Yeah, a small question from my side. In your timeline on the 2022, it had a box at the bottom stating sale of spin-off products. Could you clarify that a little bit?
Yes, indeed. So to make these thermoplastic composite pressure tank, NGT needs an intermediate product, so carbon fiber tape pre-impregnated with thermoplastic polymer. We are developing this material in-house because we need it for the pressure tank, but that's also an intermediate product that can be sold on the free market on the short term to generate short-term sales.
Okay, thank you.
You're welcome.
Okay, well, thank you, Gilles, for your presentation.
Thank you.
And now, dear expert, you can review new generation tanks in our online evaluation forum. And I would like to invite Daniel to prepare his slides. Daniel, do you hear us? Oh, you're muted.
Yes, sorry.
No problem. Take your time. Okay, we see your screen. Okay, perfect. We will begin very shortly. Thank you. Okay, if you feel ready, you may begin your presentation.
Good. Good morning. My name is Daniel Verbaan, and I would like to introduce to you a new technology to produce pure hydrogen and pure oxygen by the use of ultra high temperature. It's safe, energy efficient, and low cost. To change from hydrocarbons to only hydrogen as an energy source, it's a very hot topic these days. Hydrogen is the way to decarbonize the world and mainly the industry. But how can we produce enough hydrogen in a green, energy efficient and safe way? We think we have found a different solution to produce pure hydrogen and pure oxygen with the same installation. We have validated our technique. We have partners and customers ready and a clear development strategy. Just to give you some idea, 1 kilo of hydrogen contains approximately 35 kilowatt hours. It takes approximately 50 kilowatt hours to produce 1 kilo of hydrogen. The difference is more or less wasted in heat losses. The technology we introduced to you is called thermolysis. If you heat water to 2250 degrees Celsius, the water molecule breaks into hydrogen and oxygen. We call it our water splitter. The system needs water, electricity, and can use any waste heat coming from existing waste heat sources. The hot gases, hydrogen and oxygen, are cooled with ceramic heat exchangers to preheat ingoing water. To reduce energy cost even more, the system can use available waste heat coming from other energy sources. Any steam temperature above 105 degrees Celsius is welcome in order to reduce electricity usage. Our electrical energy consumption is approximately 20% less compared to other electrolyzer technologies. The water splitting is very high temperature, is yet unexplored but known physics. to investigate this idea, the founders of the water splitting technology started around the year 2000. Several proof of concept were built in laboratories long before the topic of changing the energy demanded to hydrogen was on the agenda. 2 years ago, we came in contact with the founder of this technology and started with our goal and project to bring this technology to the market. As you can see, we have compared our technology with steam methane reforming and electrolyzers. All green hydrogen produced starts with green electrical power. The reactor is completely ceramic based, 20% less OPEX and 20% less CAPEX. And because of the separation in pure hydrogen and pure oxygen, it's safe. We think we can be 20% less electrical power consuming compared to other technologies. Imagine, for the same output of hydrogen and pure oxygen, 20% less wind turbines or solar panels. Our first target markets are the heavy-duty mobility users like the high-end transportation industry. The oxygen coming from the water splitter will be used to replace normal combustion air with pure oxygen. For example, the oxy-combustion industry. We have, and we will, in-house ceramic filter production, several patents on several ceramic parts, more IP development during assembling of the water splitting, and our strategy is direct sales of water splitting and hydrogen/oxygen as a service can be offered and is part of our business strategy. Our basic team is ready to start, and you can see that our founder, Niels Kongmark, is also joining and working in our team. What we've done so far and what will be our planned future, we will, to start, the proof of concept number 5 was built. You can see the picture on the left side. Our first goal is to build a pilot installation to split 18 kilo water per hour. The output is 2 kilo pure hydrogen and 16 kilo pure oxygen. We have established contacts with HydroHub and Brainport in order to build our pilot. For this part, we are looking for 4.5 million euro. Our second goal is to build our first commercial demonstrator. We do have an interested customer who will use the hydrogen for transport purposes. The oxygen will be used in their existing heavy combustion process to reduce NOx, CO2, and other flue gases. For this part, we are looking for 5 million euro. We have spoken to many national and European grant supporters. Our story and goal is very appealing and does fit in very nicely at the current programs. We think we are able to raise at least 50% of our total financing with grants. Thank you for your attention. And my name is Daniel Verbaan, and I would be happy to speak to you later.
Great. Thank you very much, Daniel, for the presentation. Now we give the floor to our experts. Whoever is ready may begin.
Daniel, thank you very much for the presentation. Looking a bit in the future, when you have established your technology, what kind of business model will you choose? Will you sell the technology, license it, or operate it yourself?
We have 3 or 4 possibilities. It's like the sale of the water splitter directly, so the customer can operate it themselves. We also can sell licenses. We would like to sell licenses, but as I said before, we would like to produce the semiconductor filters ourselves. So you can build in license, but you buy the filters from our side. We can also operate to supply hydrogen and oxygen as a service. And yeah, so many possibilities are available. Yeah.
Okay, thank you. And do we have any more questions for Daniel?
Yeah, I have another question, Daniel. Thank you so much for the nice presentation. I know you are in an early stage, but you say yourself it's good to be true. So do you already have a business partner? or a strategic investor?
No, we are at the moment of, we do have an end customer of the commercial demonstrator who is interested to, I can show you later. We are looking for the best opportunities for us to build our pilot plant. And we are looking also for the best environment to build our pilot plant. That's why we are in contact with HydroHub, and we are in contact with Brainport, and we are in contact with Vlissingen in Zealand, in Holland. And we would like to work in an environment which has the best opportunity for our pilot. And sometimes also you have to follow the money a little bit. It means that yeah, sometimes you must cooperate, and we will cooperate with companies who are willing to help us out. But yeah.
Okay. I know the locations you mentioned.
Yeah.
So
they're very eager to set up this pilot plant next to the electrolyzer test plants they are already set up, and they want to compare and combine yeah, the results from our pilot installation to the electrolyzer installations.
Understand. Thank you so much.
Okay, and we have time for maybe one more question if anybody has. Okay, then thank you, Daniel, for your time and for your presentation. Now, dear experts, you can evaluate ultra-high temperature processes in our online evaluation forum. And I would like to invite our last company of the day, which is Hysamite TSD Technologies, and Mati to prepare his slides. Okay, we see your screen.
If you see the screen.
Just maybe presentation mode. Yes, perfect. Thank you very much. We will begin in half a minute, just to give some time to our experts.
No worries.
Okay, if you're ready, you may begin your presentation.
Okay, thank you, Tina, and greetings to everybody from Luleå, Sweden, where I'm at the moment participating in the German Nordics event on hydrogen and visiting the first carbon neutral steel plant. So my name is Matti Malkamäki. I'm the chairman of the board and founder of Hysamite, and what we are. So in order to reach the climate goals, industry needs to move fast to its hydrogen economy. Existing solutions to provide clean hydrogen is too expensive. Also, an ecological alternative has to be found to graphite, which is one of the critical materials in the EU. Hysamite has developed a technology to produce hydrogen via breaking methane or biomethane into clean hydrogen and solid high-quality carbon without any CO2 emissions. Hysamite can provide clean and affordable priced hydrogen for industrial customers. The technology is based on university research and know-how, but the technology is our own IP. We need a proof of concept in industrial scale, so we are building an industrial scale demonstration site. We do it in cooperation with our strategic partners, and first agreements are already being signed. We are raising about 10 million euros equity combined with planned financing. So why hydrogen? Hydrogen is a building block of almost any chemical compound. It can be used to decarbonize many industries and applications such as metal refining, marine transportation, and power generation. Our technology is a catalyst that helps us to split methane into clean hydrogen and solid sustainable carbon with 10 times less energy, 0 emissions, at an affordable price required by the industry. It is scalable, so production meets industrial requirements. DCD process is scalable, so production is close to it can be put close to the customers as well. Catalyst is our own IP. We have over 20 years of research behind our innovation. Catalyst is an environmentally friendly and it is regenerated in a sustainable way. It is also recycled after the use. We are developing a catalyst family that enables us to make different kinds of carbon. As earlier said, as a byproduct, we get very high quality clean carbon, which is used in several industries that are critical for the future of Europe. Batteries, composite materials, activated carbon applications. And we have already tested our carbon in batteries. These carbons are now imported from Asia. We produce them in Europe. Sustainable carbon as a secondary product is supplementing the sales. Compared to other production technologies, Hycamite CCD has no CO2 emissions and requires less energy per produced hydrogen. Only 10% of the energy compared to the green hydrogen, i.e. electrolysis. We have a lab scale testing, but also a small scale pilot plant. The natural next step is to build an industrial scale demonstration site for piloting. Scaling up is done with strategic partners. For this, we have already signed agreement on the area reservation and delivery of the natural gas. We have also signed an agreement with Speco, a highly evaluated engineering company in the Nordics, about designing the plant. Now we are seeking for the financing of this site from public and private investors. We need a proof of concept in industrial scale, so we are building this demonstration plant. We are raising 10 million euro equity combined with plant financing for building the demo plant for plant operations. In order to scale up, we need to have a proven business model as well. We have discussed about our business model together with our strategic customers. The proposed business model is based on direct sales of our main end products, high value added, solid carbon and clean hydrogen. The sites will be located close to hydrogen customers to avoid unnecessary investments into infrastructure. Long supply agreements will give security to asset investors financing the plants via SPVs. The sale of commodity carbon and possible combination with carbon emissions trading will be added as deemed possible. The sites will remain under our operations. This way, the business model can be truly scalable to enable the quick internationalization. This is where we are located, Northern Europe's biggest industrial park of inorganic chemistry in Kokkola, Finland. In the small picture on the left, you can see our existing small-scale pilots. It's behind the logo here. We have rented 1.3 hectares of land in this area where we will build our first demonstration plants. So how do we do that? We have a highly qualified team. Our current team consists of experienced scientists, engineers and business developers, and we have top-notch board members and advisors, including energy industry executives and serial entrepreneurs with extensive contact networks. We'll strengthen our team on business side in the coming years as the demonstration side continues. So hydrogen is the energy of the future, and the only way to fight against climate change is to have the industry convert to hydrogen. It is time to act now. We look for strategic investors to join us on this 10 million euro round A, and we welcome especially industrial strategic investors that have a need for hydrogen and or high value solid carbon products. I'm happy to discuss with you afterwards. My name is Matti Malkamäki. I'm the chairman of the board and founder of Hycamite.
Great, thank you very much, Matti, for your presentation and for being on time. Now we give the floor to our experts for questions. Okay, Max.
Hi, thank you again from my side for the presentation. I wanted to ask you regarding the purity of the hydrogen that comes out of the process as of today. Could you give us a comment or feeling to that?
Well, sorry about the background noise, first of all, because I'm not in the office, if seen. But this is the process figure, as you can see. I mean, or the way that how it is being produced, and the conversion rate that we are now reaching from the reactor as a natural means is about 92%. But we can upgrade the hydrogen. I mean, we can separate the methane from hydrogen by using the already existing technologies like pressure swinging, absorption, filtration units, and so forth. So we can get to 100% or 99.9999% hydrogen in case needed. But actually, most of the customers at the moment are happy to have just, you know, a raw hydrogen or a mixture of hydrogen and natural gas in the initial applications.
Okay, so they're not actually looking for this 99.999.
We have at the location where we are in Kokkola, we have a couple of companies that are using hydrogen for the cobalt refining, and they need to have high purity hydrogen, which we will then deliver to them. I mean, this is existing technology; it's not an issue. But all the other customers so far have been seeking only for something between 20 to 50% hydrogen as a mixture of hydrogen and natural gas. And this means that not even all the gas that we are doing, they would use as such, but they want to blend that with their natural gas.
Thank you so much, Matti.
Hi, Matti. Thanks also from my side. Quick question. Two questions. Have you calculated which price or costs you can reach when you scale up your method? Question number one. Okay.
Yeah. Yes. We think that the change from the gray hydrogen to low carbon hydrogen that what we are producing will take place only when the price is about the same or with a very small premium to gray hydrogen. And this is what we can reach. So at the moment when we are calculating the hydrogen cost for €2 per kilogram of hydrogen, which is about the size or about the range that what we have existing in Europe for industry, we think that with a sales price of €590 per ton of carbon, we can make the units working with a 17 to 21% pure profit after all the depreciations and everything. So we should be quite well into profitable figures already now.
Okay, and thanks. And second question, how do you deal with the carbon clogging up the reactor during the production process?
This is a low temperature reactor, so that the carbon clogging that you refer to is something that takes place mostly in that kind of reactors where you have, you know, more than say 900 degrees of centigrade or so that the carbon gets stuck to the reactor walls. But in our case, the reactor temperature is about 600, and we haven't seen, you know, excessive amount of clogging in the reactors so far. So of course we need to continue the tests, but so far it hasn't been an issue.
Okay, and do we have any more questions for Matti? Okay, then thank you, Matti, for your time and for your presentation.
Thank you.
Yes, I will ask you to stop sharing your screen. Thank you. So, dear participants, that was all for today. We hope our breakout session was interesting and useful for you. Now, all companies will soon receive via email their evaluation results and a video recording of their pitch. Now, we kindly ask you to complete our feedback survey that you will see now in the chat. And also, I would like to remind you about the one-to-one meetings option. They are starting today from 2 p.m. and will continue until 26th of November, all of the day. So you can still book your one-to-one meetings with different experts or even companies. I would like to thank you for joining us today. And for being part of Invest Horizon Sustainability eForum. I wish you a wonderful day, and I hope that we will see each other soon. Thank you.
Thank you, Tina.
Thank you.
Bye.
Thank you.
Thank you very much. Bye-bye.
Thank you. Bye.
Thank you so much.